Hello, this is Mrs. Greathouse. Our lesson today is about percent composition and empirical formula. First up, percent composition. It is the relative amounts of the elements in a compound expressed as percent of mass. And we are going to use molar mass. Okay, imagine you're doing laundry and you're looking at the tags inside the clothes to find out what they're made up of. This information is important to us because it tells us how we want to wash our clothes. If a t-shirt is 100% cotton, we definitely know that we don't want to wash it in hot water and put it in the dryer. But if we see that the tag is 50% cotton and 50% polyester, we know that it can go in the dryer and not shrink too much. Okay, percent comp of compounds are going to be very similar. It's going to tell us how much of each atom is in this compound as a percent, and we will compare molar masses. Okay, let's use potassium permanganate for our example. Okay, let's find the molar mass of the total potassium permanganate. So potassium is 39.1 grams per mole. Manganese 54.9 grams per mole. Oxygen, we have 4 of them at 16 grams per mole. So we'll multiply those, total them, we get 158.0 grams per mole for a molar mass of potassium permanganate. Now we want to find the percentage of each element by mass. Okay, just like when we figure your percentage for a test, we figure how many you got right out of the total and multiply by 100. Same idea here. Potassium. Okay, what is its part of the mass? 39.1 divided by the total, 158.0 multiplied by 100, and we get 24.7% potassium. Next one up, manganese. The part that's manganese is 54.9 grams per mole. Out of our total, 158, divide those two, multiply by 100, we get 34.7%. Oxygen, we have to look at all 4 of our oxygens. So the molar mass is 16 times 4, which is 64, divided by our total, again 158.0 times 100 gives us 40.5%. We can do a quick double check here. Our totals of our percentages should be really close to 100%, give or take a few tenths due to rounding. Okay, that is how we find percent composition. Okay, next up, empirical formula. Empirical formula is going to tell us the lowest whole number ratio of the atoms of the elements in a compound. Okay, for example, we have written here ethene, which is a gas that's used in welding. Its molecular formula is C2H2. Okay, we have styrene, which makes up polystyrene, or styrofoam, which is in those little packing peanuts. Okay, its molecular formula is C8H8. If we look at the lowest whole number ratio of either one of these, they're both CH. Okay, so even though their molecular formulas are different, their empirical formulas are the same. Okay, so how are we going to use this as a practical application? Let's say we're working in the lab and we have analyzed a substance and found that it's 25.9% nitrogen and 74.1% oxygen. Okay, to make this easy for us, we are going to assume that we have 100 grams, and 25.9 grams of it is nitrogen, and 74.1 grams of it is oxygen. From here, we're going to calculate moles with moles equals grams over molar mass. Okay, so for nitrogen, that would be 25.9 over 14.0 is molar mass, and that would give us 1.85 moles. Okay, do the same with oxygen. Grams over molar mass will give us moles of oxygen. If I divide that, I will get 4.63 moles of oxygen. Okay, I'm not in whole number ratios yet, so I need to make my smallest amount of moles be the 1 in my ratio. Okay, so what I'm going to do is I'm going to divide 1.85 by 1.85, and I'm going to get a 1. That's the basis for my empirical formula. What I do to one element, I have to do to both. So I will divide 4.63 by 1.85, and I'll get 2.5. Getting closer, but still not in whole numbers. I have this decimal over here. If I multiply 2.5 times 2, I will get 5. Yay, I got rid of my decimals and I'm in whole numbers. Okay, I have to do to one what I do to the other. So I multiply my nitrogen moles by 2 and I get 2. So now I know that my empirical formula for what I found in the lab is N2O5. Okay, it could be dinitrogen pentaoxide or any factor of that. It could be N4O10, but this, the simplest whole number ratio, is going to be our empirical formula. Thanks for listening. I hope you took good notes. Bring me your questions. See you next time.